Hey everyone, this is Nathan. Today we are going to look at a Leetcode medium problem, which is number of islands. Um, this question has been asked by Amazon, Bloomberg, Facebook, Microsoft, Apple, Google, and other companies. So this is quite a um, popular question out there. So let's go over the question quickly. Given a m cross n 2D grid map of ones land and zeros water, return the number of islands. So here 1 represents land and 0 represents water. Now let's see what island means. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all 4 edges of the grid are all surrounded by water. So the question here asks like, since 1 represents land, we need to find the number of lands grouped together that are connected to each other either vertically or horizontally. If you see the example 1, this whole bunch of ones are together which are connected either vertically or horizontally. That's why the output is 1. In the other case, if you see, these is bunch of ones. This is not connected either horizontally or vertically, hence it's connected counted as a separate island, and the same goes for last thing. Let's quickly take a look at the whiteboard session to see how we can proceed further. From problem description, we understood 1 represents a land and 0 represents water. An island is nothing but a group of ones which are connected horizontally or vertically, and our job is to find the number of islands here. Let's go over the first example that we have over here. If you see, the number of ones that are connected horizontally or vertically would be this section. So here the answer is going to be 1. The reason being, all these ones are connected to each other either horizontally or vertically. So now let's take a second example to see how it works differently. This is going to be one island, and we are not connecting this one to this one because it's neither connected horizontally or vertically, but it's connected via a diagonal. So we cannot consider this as a valid case, and hence that is not accounted for, saying like that is a connected island. And if you see this one, this is not connected to any of the ones either horizontally or vertically, so this alone will be a single island, and these again are not connected to anything else, so these alone would be connected to different islands. So here the answer would be 3 islands. So generally, if you see these kind of things, you can think about as a graph, and in graph we have two kind of traversals. One is like DFS, depth first search, another one is a breadth first search. If you're not aware of graph, its representations, and the traversal methods, I kindly request you guys to go refer to online materials to learn more about that, because we need that data to be available here to be able to continue doing this problem. So this problem can be solved either with a DFS or via BFS, but since a DFS can be solved recursively, it's a lot easier for us to handle these cases. In DFS, we're gonna do is like, I'm gonna go ahead with the first problem, the second example that's been provided, so that we can see how things work better. So let me clear this area to make some space. So if we have 1 1 0 0 0 and 1 1 0 0 0 0 0 1 0 0 0 0 0 1 and 1, and m is gonna be this way and n is gonna be this way, I will start traversing my graph representation from left to right and from top to bottom. Whenever I see 1, I ensure that 1 is replaced by 0. So since you do know in graph traversal, we visit its current element and then it's all its neighbors. So here first thing is gonna be this would become 0, and then I'm gonna visit its neighbor. It could be the right element or the left element, anything works fine. So here I'm gonna visit the right element 0, and next I'm gonna visit its own neighbors. So we don't have anything towards the right side, so we look at the, there's nothing to the top, left is already 0, then we look at the bottom, so even this one becomes 0. And here in this 0, if you see again, top, right, bottom is 0, so we're going to visit its left and change it to 0. And once we come to this element, we have recursively followed this path and there is no more path forward for us to go, so we return back the recursion and go back to the original case and count this one as 1. Now we skip all the elements wherever 0 is present, and we are still traversing from left to right, top to bottom, and we finish first row, second row, and when we come to third row we see like another 1. So we replace this 1 with 0, and then we see all its neighbors. There are no neighbors either horizontally or vertically, so this is going to be plus 1. And then we continue searching forward, and again we see 1. We replace that with 0 and visit its neighbor, which is again 1, replace its element with 0 and add the elements results here, that equal to 3, and we're gonna return these results. So this is the DFS method. We can achieve the same solution even with BFS, but DFS is much easier for us to write code in an interview because it's recursive and easy to handle things. If you see the runtime complexity here, we are visiting all the elements in the original graph from left to right and top to bottom. So my time complexity is m into n, where m is the row and n is the column. And the space complexity is still gonna be m into n. The reason being we are following recursion and we are gonna following things in automatically use inbuilt stack, and if the entire array is filled with lands, we're gonna recursively go in depth of m cross n, and hence we claim the space complexity as m into n. Now let's quickly go over the implementation. Now let us implement the DFS for the number of islands. The first thing is like the result. Let's declare a variable interest equal to 0 and check for the valid cases of the inputs being provided. If my grid dot length equal to 0 and grid equal to null, in either cases I'm just gonna return the result. Now that we clear that, we need to traverse our graph from left to right and from top to bottom. So for that I'm going to use two for loops. So I is gonna be my row and j is gonna be my length, sorry, the column. So once I do this, next thing is like I'm interested in only land, like we could come across land or we could come across water. We need to consider only when we come across the land. So if grade of I j equal to 1, in which case I need to do a DFS call from this position and see all the ones that are connected to this one land either horizontally and vertically, and convert them into water and increment the result by 1, saying like we have found one island. So let's invoke a method called DFS, which is not implemented yet. We'll soon implement that, but we're gonna pass in the grid and the row and the column. Once that is done, we need to just do increment on the result. So that is the only thing that we need to take care over here, and that would let me do a braces over here for the readability part. And once this is done, we are gonna just return the result out here. So all I'm trying to do is like traverse the provided 2D matrix from left to right and top to bottom, and whenever we find a land, see all the lands connected to this land either horizontally or vertically, and convert them, mark them as a water, and increment the result by 1, which is the number of islands. Let's quickly jump over to the DFS implementation. This is going to be my DFS method, and if you see, it's going to accept 2D character grid, intro and in column. This is the position at which we have found the initial land. DFS itself can be the easy implementation, the reason being it has a generic template for a recursive solution, which we can take advantage over here. So let me break it down in this case. One is going to be base condition, another is going to be process, call DFS as. So these are all the 3 steps that we need to follow in DFS call of any 2D matrix. So before we get into that, let's see like the inputs that we need. I want to know the number of rows. That's going to be grid.length. Grid.length gives me the number of rows present in the grid, and grid of 0.length gives me the number of columns present in the grid. The base condition is like, since we are calling the elements in a recursive fashion, there are 2 things. One is like I need to ensure the elements that we visit are always within the boundary of the given 2D matrix. Like we don't want to go outside these boundaries. So that's going to be So whenever we see like in a recursive call, we have gone outside the boundaries of the given matrix, we need to return there. So this is one of the base condition. Another base condition that is specific to problem. That's going to be like we are interested in only land. Whenever we come across any water, we need to not process any further. So for that, we are going to return that because we are interested only in land, not in water. Hence, whenever we see water, we return that. So these are all the base conditions that we need to take care of in a DFS for this specific problem. And in case of processing, like I mentioned previously, whenever we encounter a land, we just need to convert that into water. So that's going to be so when the moment I enter line 33, it means I'm looking at land. So I'm gonna straightforwardly call, convert that into water. The next one is gonna be like calling these functions recursively. So how do we find out what are the calls that we need to do? The problem clearly specifies the island is nothing but group of lands connected either vertically or horizontally. So we need to call for left, right, top and bottom. So I'm going to create a separate variable here for the directions. So this makes easy for me to see on what are the directions that I'm calling in. So here this one is left, this one is going to be my right, this one is going to be my up, or I can name it as top, bottom. So these are all the 4 directions that I want to recursively make my DFS calls. So over here all I need to do is for I just need to make recursive calls for again for DFS method, and that's gonna be using this, and I need to say so that completes the recursive calls. That does it. I had a couple of issues, so I did not pass in the grid element over here first. I forgot to put the semicolon, and here I had declared as an int instead of a 2-dimensional integer array. Once I fix that, the solution is working, and this is a much feasible and readable code which you need to try and aim explain the solution, runtime and space complexity within 45 minutes of your interview schedule. Thank you for taking a look at this video. Have a good day.